Let's start with clean star closure. So, given sigma, then the clean star closure of alphabet sigma, denoted by sigma star, is the collection of all strings defined over sigma including lambda. It is to be noted that the clean star closure can be defined over any set of strings. Now here we will take the value of a star as 0, 1, 2, 3, 4 and so on. Let's explain the some examples. Let's say sigma is equal to x. Then sigma star is equal to lambda 1 times x, 2 times x, 3 times x, 4 times x and so on. So the values of a star are 0, 1, 2, 3 and so on, which are imposed on x. Similarly, if we take the example when sigma is equal to 0, 1, then sigma star is equal to lambda 0, 1, 00, 01, 10, 11 and so on. And similarly, we have double A, B and C, so we will get this type of language. Let's see how this closure operator works. So, if sigma is equal to x, and we are familiar that star is equal to 0, 1, 2, 3 and so on. So when x is equal to 0, so that makes lambda. When x is equal to 1, that produces 1x. And x bar is equal to 2, so it produces 2 times x. And 3 times x, 4 times x and so on. Thus, sigma star produces lambda 1 times, 2 times and so on. So this is how closure operator works. Note, language is generated by clean star closure. The important thing of these languages is that the set of strings are infinite. It means the number of strings in these languages are infinite, but each word is of finite length. Plus operator or plus operation, this is quite similar to star operator, except that it doesn't generate null string. Let's say if sigma is equal to 0, 1 and now we are taking sigma plus. So it contains 0, 1, 00, 01, 11 and so on. If we have another example, let's say sigma is equal to double A, B and C. So we will have sigma plus is equal to double A, B, C, double A, B, double A, B and so on. Plus contains 0, 1, 2, 3, 4 and so on. Now the next topic is recursive definition of a language. There are 3 steps in recursive definition of a language. Some basic words are specified in a language. Rules for constructing more words are defined in the language. And the last is no string except those constructed above allowed to be in a language. So this definition contains 3 steps. That is to generate basic word, then to define some rules, and then to accept only strings generated above are a part of the language and the rest are rejected. Now we will explain it using some simple example. So first of all, we will take a set of natural numbers. So defining a language of natural. Step number 1. 1 is in a natural number or 1 belongs to natural numbers. Step number 2. If x is a natural number, then x plus 1 is also in a natural number, or x plus 1 also belongs to natural number. Step number 3. No string except those constructed above are allowed to be in natural number. So this is a 3-step procedure. In step number 1, we will define some basic value. In step number 2, we will define some rules. And in step number 3, we will only accept the strings that are generated in step number 1 and step number 2. Now we will take the same example to define the natural numbers. In step number 1, we have defined 1 is a natural number, or 1 is taken as a natural number. So the set contains the only number that is 1 in the set. That is the natural number set. Now in step number 2, if x is a natural number, then x plus 1 is also a natural number. So it becomes the formula that will define the whole language. In the previous step, we have taken 1 as a natural number. Now what we're doing, we are adding 1 with 1, so it becomes 2. Now this language contains two strings, 1 and 2. Then step number 3, no string except those constructed above are allowed to be a natural number. So no other string generated above. It means we will jump to step number 2 once again, or you can say that this is a loop. This way, now we are generating another number. We have 1 and 2. Now take the value of x is equal to 2. So 2 plus 1, that becomes 3. Similarly, if we are taking another number, that is 3. So 3 plus 1, that's equal to 4. Then 4 plus 1, 5, and so on. In this way, we will generate a language of infinite strings. Now we have another example defining the language of whole numbers. In whole numbers, step number 1 is a whole number. Step number 2, let's say x is a whole number, so x plus 1 and 1 minus 1 are also in whole number. The same condition, no other string. Let's explain the previous example. That is the whole number. So 1 belongs to a whole number. This way we will have 1 as a set, as a number of this set. That is the whole number set. Now if x is a whole number, then x plus 1 and 1 minus 1 are also whole numbers. This way we will get 1 plus 1, that is 2, and 1 minus 1, that becomes 0. Now we have 3 members of this set. Once again, no other string. So 0, 1, 2. Now we will add 2 with 1, that becomes 3. Then 3 with 1, that becomes 4, and so on. Now we will have another example defining language of even. So in even, 2 is an even number. So step number 2, let's say x is an even number, then x plus 2 is also an even number. Step number 3, no other number that generated above belongs to even number. Now we will explain the same example. So if 2 is an even number, now the set consisting of only one number, that is 2. Now x plus 2. So if we take x plus 2, so it becomes 2 plus 2, 4. Then 4 plus 2, 6, 6 plus 2, 8, and so on. Thus we will generate an infinite language. Now we have another example, that is integer. So step number 1 is an integer. Step number 2, x plus 1 and x minus 1, both are integers. This way we will have 1, 2, 3, 4, and so on. Similarly 0, minus 1, minus 2, minus 3, and so on. And we will have the set of natural integers. Let's take another example, that is factorial. Step number 1, 0 factorial is equal to 1. So 1 is a factorial. Step number 2, n star n minus 1 factorial is a factorial set. Step number 3, once again no string except above are called factorial. Now we have another example, that is palindrome. So sigma is equal to AB. Step number 1, A and B are in palindrome. Step number 2, if x is in palindrome, then s of x and reverse of s and double x will also be a palindrome, where s belong to sigma star. Step number 3, no string except those constructed above are allowed to be in palindrome. Now defining language A and Bn. So n is equal to 1, 2, 3, and so on. Defined over AB. Step number 1, AB is in A and Bn. Step number 2, if x is in A and Bn, then AXB is also in A and Bn. Step number 3, same as we discussed before.